Hi everyone, welcome back to the channel. Today we are diving into one of the most important services in AWS, and that is EC2. EC2 is at the heart of the AWS ecosystem. Whether you are just starting with AWS or you are looking to strengthen your basics, this video is definitely for you. Make sure to stay till the end because we have some exciting demos lined up that will make everything much clearer. Let's get started. Let's start with a quick introduction to Amazon EC2. Amazon EC2 stands for Elastic Compute Cloud. It provides on-demand scalable computing capacity in the cloud, which means we can launch virtual servers whenever we need them without any upfront hardware investments. It also helps us to reduce hardware cost and accelerate our development process so that we can focus on building and scaling our applications faster. We can launch as many or as few virtual servers as we want and easily configure security, networking, and storage based on our needs. Plus, EC2 gives us the flexibilities to scale up during high demand periods and scale down when traffic drops, helping us to save cost efficiently. Let's now look at some of the key features that makes EC2 so powerful and flexible. At the heart of EC2, we have instances. Think of this as your virtual computers running in the cloud. To launch them, we use something called an Amazon Machine Image or AMI, which is like a ready-made template that comes with the OS and software pre-installed. Now, depending on the workload, we can choose different instance types. Maybe we need more memory, more compute power, or more storage. AWS gives us that flexibility. For storage, EC2 offers EBS volumes for persistent storage. Great if we want our data to survive reboots or stops. On the other hand, instance source volumes are temporary. They are fast, but the data disappears when the instance stops. To connect securely, EC2 uses key pairs. AWS provides us the private key and it keeps the public one with itself. It will be like a lock and key model for SSH access. And lastly, security groups. These are like firewalls, letting us define what kind of traffic can reach our instance and what traffic our instance can send out. Each of these features plays a big role when we actually work with EC2, and we will see them live during our demo. Before we jump into EC2 instance types, it is important to quickly understand the difference between CPU and memory. Let's look at them now. CPU, Central Processing Unit, is like the brain of our machine. It handles all the logic calculations and instructions. So if our apps is doing a lot of computing, like encoding videos, running ML models, or handling thousands of requests, we need more CPU power. On the other hand, memory or RAM is like our workspace. It's where our app temporarily stores data it's working on. The more memory we have, the more data we can handle at once. It is useful for applications like in-memory databases or data-heavy analytics. So depending on our workload, whether it's compute heavy or memory heavy, we will choose the instance type accordingly. Let's now look at the different types of EC2 instances, categorized based on the kind of workloads they are best suited for. General purpose instances offers a balanced mix of compute, memory, and networking. These are great for everyday workloads like web servers, dev or test environments, and code repositories. Examples T3 and T2, etc. Compute optimized instances are designed for CPU heavy applications. If our workload needs fast processing like batch jobs, video encoding, machine learning inference, or gaming servers, this is the type to go for. Example C5 and C6G, etc. Memory optimized instances are built for tasks that need a lot of RAM, perfect for in memory databases, real time big data analytics, or large caching systems. Examples R5 and R6G. Based on our app's needs, we can choose the right type to get the best performance and cost efficiency. There are even more types like storage optimized and accelerated computing instances. Let's check those out next. Now let's look at the specialized EC2 instance types for more advanced workloads. Accelerated computing instances. These instances use hardware accelerators like GPUs and FGAs to speed up tasks like graphics processing, machine learning training, and complex calculations. If we are working on AI, ML, or video rendering, these are the way to go. Examples P5, P4, etc. Storage optimized instances. These are built for workloads that need high speed, low latency access to large data sets and can handle millions of IOPS. Think of them as the go to choice for data warehousing, big data analytics, or high performance databases. Examples I3, I4I, etc. HPC optimized instances. If we are running large scale simulations or doing deep learnings, these instances are designed to deliver the best performance for high performance computing. HPC. They are perfect for scientific research and engineering applications. Example, HPC 6A and HPC 7A are some of the common examples for HPC optimized instances. So if we are running simulations for space research or using machine learning to process huge data sets, we want to use these specialized instances to ensure fast performance and efficiency. Let's now dive into the various pricing models for EC2 instances. Each model is tailored to different use cases depending on how predictable our workload is and how much we are willing to commit. To make this clearer, think of the pricing model as similar to subscription services like Netflix or gym memberships. Now let's break down on each model. On-demand instances. This is the pay-as-you-go model. You don't need to commit to anything and you pay only for what you use. Think of it like paying for a Netflix subscription month to month. It's ideal for short-term workloads or unpredictable ones. Reserved instances. Here you commit for a 1 year or 3 year period, and in return, you get up to 72% savings compared to on-demand pricing. It's like a gym membership where you commit to a longer term and get a better price. Reserved instances are perfect for steady and predictable workloads like always on applications, databases, or core infrastructure. Spot instances. This allows you to use spare capacity in AWS with discounts of up to 90%. It's similar to buying off peak tickets for events or travel, where you get a great price but have to be flexible about when you use it. Spot instances are perfect for flexible workloads that can handle interruptions like batch processing or data analysis jobs. Savings plans. This is a more flexible version of reserved instances. With saving plans, you commit to a certain usage level in exchange for discounts, but you can choose between compute saving plans covering both EC2 and Lambda or EC2 instance saving plans. It is like a flexible subscription that adjusts to your needs over time. Now let's briefly talk about dedicated options in EC2 for scenarios that require physical isolation. This is like renting out an entire physical gym space rather than just reserving a single machine. Here's the breakdown. Dedicated host. These are physical servers fully reserved for your use. You get OS level control, which is ideal for workloads that need licensing or compliance requirements. It's like renting the entire gym for yourself, where you have complete control over the space and equipment. Dedicated instances. These run on dedicated hardware, but without OS level control. It's great if you need isolation, but don't want the overhead of managing the physical server itself. Think of it as a reserved section in the gym just for you, but without the full control over the whole space. Now that we have covered the key concepts and components of EC2, it's time to look into one of the most important elements in networking, IP addresses. IP addresses are essential for communication between instances, both internally and externally. Understanding the difference between private IP and public IP is crucial when designing and deploying our EC2 instances, especially when setting up secure scalable architectures. In AWS, managing IPs correctly is key to ensure that our instances can communicate the way we want them to, whether within our VPC or with the broader internet. Let's dive into the details of private IP and public IP and explore when to use each. These two types of IPs serve different purposes, and it's crucial to understand when to use each one in our AWS environments. Private IP used within a local network like our VPC. Here VPC means virtual private cloud. Private IP is not reachable from the internet, so it's more secure for internal communications. Private IP is primarily used for internal apps and communication, such as connecting our web servers to databases. Think of it like a phone number that only works within our company, ensuring no external calls come through without our approval. Let's see about public IP. Assigned to an instance for internet communication. It is reachable from the internet, thereby allowing external users or systems to interact with our resources. Public IPs are commonly used for instances which require external access, like web servers that need to be accessible by users on the internet. However, public IPs are dynamic and they can change when we stop or start an instance. If we want to maintain a static IP, we can consider using Elastic IP. Elastic IP ensures our public IP remains constant even after instance restarts. In essence, private IPs keep things secure within our network, while public IPs allow our instances to interact with the broader internet. Now let's talk briefly about Elastic IP. Elastic IP is a static IP address designed specifically for dynamic cloud computing. Unlike regular public IPs, it's tied to your AWS account, not to a specific instance. The beauty of Elastic IP is that they can be reassociated with different instances, providing resilience if an instance fails or needs to be replaced. This makes them perfect for critical services that require uninterrupted public access. Charges for elastic IPs only apply when the IP is not associated with a running instance, making it a cost efficient option when we need a static IP but aren't actively using it at all times. This flexibility allows us to maintain high availability and ensure that our application remains accessible even if we need to scale or recover from instance failures. It's similar to how we can keep a permanent phone number but change the device it's connected to, so your contact always reach you no matter what devices we are using. Let's now look at AMIs, Amazon Machine Images, which are crucial for launching EC2 instances with predefined configuration. An AMI is a pre-configured template that includes the operating system, software, and setting required to launch an EC2 instance. AMIs allows us to quickly launch instances with the same configuration, making it much easier to set up and manage our instances across multiple environments. We can also customize AMIs to fit our specific needs and share them with others, or use them to create multiple instances with an identical setup, ensuring consistency in our infrastructure. There are two types of AMIs. Public AMIs. They are provided by AWS or the community. They are available for anyone to use. Custom AMIs. These are user created AMIs from an existing instance. It is ideal for reuse or scaling in the future. Next, let's discuss the Hibernate feature in EC2. Hibernate save the RAM state of our instance to disk. It allows us to pause our instance and resume exactly where we left off. It is much like when we close our laptop and pick up right where we left off when we open it again. This is particularly helpful for long running applications or development environments where we don't want to reinitialize everything every time the instance starts. Instead, we can hibernate and continue seamlessly without losing any data in memory. With that, we have now covered the core concepts of EC2 from instant types, pricing models, IP addresses, elastic IPs to AMIs and Hibernate. Understanding these building blocks is super important because they form the foundation for working with any cloud infrastructure on AWS. Now that we know what EC2 offers and how to make smart choices based on our application needs, it's time to jump into some hands-on demos to see everything in action. Now we are in our AWS EC2 console. We will start the demo now. First of all, I would like to spin up an EC2 instance and I will show you guys how to install web server on the EC2 instance. So I will click on launch instance. I will rename the instance as web server, and now we will choose the Amazon machine image. As we have discussed in theory, we can see a lot of flavors here. For this demo, I'm going with Amazon Linux. So I have selected Amazon Linux. Under Amazon Linux, we have also some varieties. Here I will go with Amazon Linux 2 AMI. Amazon Linux 2 is also under free tier eligible, so we will not cost anything for doing this demo. Now we have been asked to choose the instance type. As we have discussed, we have the option to select whatever the instance type we want. If you see, we are seeing a lot of different types of families. For this demo, since it's a simple web server, I'm gonna go with t2.micro. t2.micro also comes under free tier, so we will not cost anything for doing this also. In this demo, we will use a keeper to SSH into the instance. Usually we connect to SSH using EC2 Instance Connect in our previous sessions. In today's demo, I will show how to connect to the EC2 instance via the keeper. So I will just create a new keeper. I will just rename it as web server key. So it will ask the format whether you want PEM or PPK. I want to go with PEM. So once you click on create keeper, our key get downloaded. Now move on to the network settings. In the network settings, I'm not going to do any changes. I will leave it as default. But if you want to see, I will just show you. So this is nothing. Our instance is launched in a default VPC. This is a public VPC, so we will be having access to the internet. And subnet also, I'm not going with any subnet preference. I'm going to launch this instance with a public IP. So because we are going to access the instance over internet, so yeah, in this option I'm giving auto sign public IP as enabled. Suppose if you want to spin an instance with only private IP, you can disable it. Now comes the important part, security group. We are going to create a new security group, so I will just rename this as web server security group. Under if you see now, we can add rules here. So I'm just going to add security group rule. So currently only one rule is allowed, that is SSH type, and the port range is 22, which means anyone can log into the instance via SSH even from internet. So I will add on one more rule so that we can access our web server over the internet. I will use the HTTP protocol, and port range is defaultly chosen as 80. So it will ask the source type. Here I will choose anywhere. There are three options. You can choose anywhere. Anywhere means anyone can access your EC2 instance from the internet. Custom, you can pass specific IP addresses that can only access your system. And my IP means this is also only your internal network or whatever the network you are currently in, that only can access this. So this is called my IP. So for this, I just go with custom, and I'm just going to give it. So this will allow everyone to access our instance. So EBS volume, I just leave it as default. I'm just having a 8 GB of GB2. So I'm going to launch the instance. So now the instance launch is in progress. We will wait until the instance get created. So our EC2 instance has been created now. We'll just try to open it and see the public IP. So currently the public IP is 52.66.253.225. So now we will SSH into the system, and we will try to install the web server. Whatever the steps we are doing in this demo, I have documented it in my GitHub repository. I will share the link of this GitHub repository along with the video description so that you can use this to do the demo. So if you see in the steps covered, we have already completed the first step, launching the EC2 instance. Now we will try to connect to the instance via SSH. So I'm using git bash here. So currently the whatever the key pair that we have created is present in this folder. Before going to SSH, I will just try to modify the permission of the key pair. Now the permission has been made. So now I will try to SSH into the instance. So there is a command we can use to SSH. This is a command. Here you need to change the key.pim with the actual key.pim. So here the key.pim is web server key.pim. EC2 user is the username. Depends upon the OS we have chosen, the username will change, and we need to replace the public IP field with our current public IP, which is nothing but. So now I will try to SSH into the instance. So now we are inside the instance. We have successfully SSH into our instance using the key pair we have generated. So now we are inside the instance. So we will try to install the web server. I will just go to the GitHub document. I will grab the commands which we can use. So these are the three commands we are going to use. First command will help us to install the web server, and second command will help us to start the web server, and the third command is enable, which will allow the service to be started at boot, which means whenever the system gets rebooted or stopped and started again, so at that time we need to go and again start the service. So while using enable, we are avoiding that issue. Once the server gets started, the service will get started along with the instance itself. So there is no manual effort needed to go inside and again start the service. So let's go and install the web server. So now the web server has been installed. So I will go and start the web server. So now the web server has been started. If you see here, the status is currently active, which means web server is running. Now I will go and enable the service to start at boot. So now the same link is created, which means whenever the system goes for stop and again start, so the service will again started by itself. So now we'll go to the browser and we'll try to access the instance from the internet. Since we have used the HTTP protocol, I'm going like this. So the web server is hosted at port 80. So now we can see the test page of our web server. It is not showing any content because we are not written any content into it. So now we will go again to the server and write some content into it, and let's see. So we are going to create a index.html. So I will just write, this is a web server created during the AWS EC2 masterclass series, or else AWS EC2 masterclass demo. So now I will close the view editor. So now we have created a new index.html and I have written some content into it. So now we will go to the website and see whether that changes has been showing. See, now the changes has been showing. We are seeing the content we have written inside. This is a web server created during the AWS EC2 masterclass demo. So now we will go to the EC2 console and we will see the powerfulness of our security group. So as you see here, we are able to access the web server without any issue. So now I will go to the security group and will remove the port 80 from the inbound rules. And let's see whether we can access our EC2 instance. So I'm going inside edit inbound rule. So I will just remove the rule which we have created for HTTP and just save the rules. Now if I try to access the web server, it will go on a loop and finally we will get cannot be reached error because in the security group we have removed the rules which have made for HTTP communication. So now the EC2 instance will not accept any HTTP related connection from the external side. So that's why our website URL is going on a loop. It is telling the site can be reached. Now we go inside the security group again and we are going to create the same rule. We are using HTTP protocol here, so I'll just use this HTTP. So the source will be, so I will just clear the rules. Now if you go and access it again, we are getting to see the output of the web server. So now we will go to the AWS EC2 console and we will see how the public IP of the instance get changed when we start or stop the instance. So now we will go inside the AWS console and we'll try to stop the instance. We will see how the public IP gets changed. This we have already discussed in our theory section, that whenever an instance is subjected to restart or stop, it loses its public IP and a new public IP will be created. As we see, currently the public IP is 52.66.253.225 and we are able to access the web server without any issue. So I'll just go into the EC2 instance and I will just try to stop it. So now we will try to stop the instance and see the public IPs get changed. So now we have stopped the instance. We will wait until the instance gets stopped. Now the instance has been stopped. We will try to start it again. As you see, the public IP has been lost. So we will try to again start the instance and see a new IP has been assigned. So see, a new IP has been assigned and it is different from our old IP. Our old IP is 52.66.253.225. If you try to access it, now it will not get access because the IP has been changed. So now we will use this IP to access our machine. Just I will change the IP. Before that I will add the protocol and will also add the port number. See, now our web server is accessible using the new public IP. Now we will again go to into our AWS console and we will request a new elastic IP and we will attach it into the same instance and we will see that the public IP remains unchanged when an elastic IP is attached. This is also something we have discussed in our theory session. If you want your public IP to not change, you can request an elastic IP and you can associate with the instance. So whenever the instance stop also, the IP remains the same. So we will try that now. I'll just quickly go into the EC2 section and I will go to the elastic IP session. So now we can see elastic IPs. Currently there is no elastic IP associated with my account. So I will just click on allocate elastic IP address. So it is asking for some options. Now I will choose Amazon's pool of IPv4 address. We are currently in AP South 1, so I will just leave it as AP South 1 I don't want to add any tags, I just allocate. So now a new elastic IP address has been allocated. Now we will try to associate it into our instance and we will try to stop it, and we will see the public IP will remain unchanged. Now I'm going to click associate elastic IP address. So it is asking whether you want to associate with the instance or network interface. I will just want to associate with the instance. So now I will go and select the instance which I have created. This is the instance. So we have associated our web server instance with this elastic IP. There are two more options available. Instead of going for instance ID, we can also associate the private IP. So this will also associate our web server to the elastic IP, but we are just going with our instance ID. So we have two options. Either we can use the instance ID of the instance, or else we can use the private IP of the instance. So if you go and see, private IP is 172.31.11.76. The same has been reflecting here. So since we have already mentioned instance ID, we don't need to specify private IP address. So this is asking an one more prompt, that is reassociation. Even though this elastic IP has currently been assigned to our web server, in the future, if we want, we can reassociate to a different instance. That is what it is asking. So for this also, I will just give a shallow. So now I will click on associate. Now it is showing elastic IP address 13.201.253.67 has been associated with the instance. Now again I will go to the instance and I will see public IP has been changed. If you see here, now the public IP has been changed. Earlier it was 3.7.73.69. Now it has been changed to 13.201.253.67. So now I will just grab the IP and I will try to access the web server. Now we will try accessing using the old IP one time. So it is getting looped and it will definitely lead to cannot be reached error. So now we will try to access it with the new IP, new elastic IP which we have been created. So now we are accessing using the new elastic IP which I have created. So now you see you can able to access. So now we will see the powerfulness of elastic IP. So I will go and stop the instance. We will wait until the instance gets stopped. Now the instance has been stopped. So we will see the public IPs remains the same. So before assigning the elastic IP, when we stopped the instance, the public IP gets lost. But now since we have associated this instance with an elastic IP, the IP remains same. So now we again try to start the instance, and now we will see the instance will come up with the same public IP. So now we can see the instance is running, and I will try to access it with the same IP. See, now the IP remains the same. Now we again go to the AWS console and we will demo the Amazon machine image creation. Currently, there are no AMIs created by me in this region. As we seen in our theory session, AWS offers two kinds of AMIs. One is public AMI, which is usually provided by AWS itself, or there will be a community. They will also provide that kind of AMIs. We can just select and use it, and we need to pay for it. And there is something called custom AMI. This is something users can create by themselves. I will tell you the real world scenario where custom AMI will be helpful. Imagine you are working in a company and you are going to do some kind of a application upgrade in a production server. There are possibility the production server may break during the upgrade or maybe after the upgrade. In this case, before the upgrade activity starts, you can create a AMI backup of the instance. So the AMI backup will create a backup of EBS volumes and whatever the packages you installed on the instance, and also its underlying OS architecture, etc. If something messed up after the upgrade and your application is down now, and you've done the troubleshooting but you are not able to figure out anything, maybe the troubleshooting will take more time. In the meantime, you don't want a downtime, so what you gonna do is, we already have a custom AMI created of our working instance before the upgrade. So at this time, we will use that custom AMI to spin up a new instance, since that AMI has all the things which are present in our properly working instance. So now the instance will come up with the good working application. So so until the issue on the upgraded instance has been fixed, we can use this instance, because here the application will run smoothly. So in a nutshell, this is how powerful custom AMIs are. So now we will go into the AWS console and we will do a demo for it. So I will just go to the instance which was currently running. I will click on actions, and there is option called image and templates. I will just click here and I will click create image. So I will name these images web server image, and I will add today's month. So this is April month, so just add April over there. Image description is optional, we can add it. And there is one more option called reboot instance. So if we click this, when the AMI backup creation is happening, AWS will reboot our instance. This is to maintain consistency, because when your instance is in stopped state, our EBS volumes doesn't have any running data into it. So at the time, if we take backup, we should not have any inconsistency. So it's always wise to reboot the instance and take the AMI backup, but it depends upon your choice. You can either click this option or not click this option, but if you click this, instance will get rebooted, so EBS will be at rest, so there is no data passed into it. So at that time, when the EBS backup has been taken, whatever the data in the current machine and whatever the data which is going to come in our AMI backup will be the same. So now it will ask about the EBS. So since our current instance has only one EBS volume, that is 8 gig, so that is a backup this AMI gonna going to take, that is what mentioned here. And we can tag our image and snapshot. So I just tag it as EBS demo. So now I'll just click on create image. So this is our AMI ID. So currently our AMI status is pending. It will take some time to create the AMI. We will wait till the AMI has been created. So now our AMI creation has been completed. You can see the status is available. We will go to the EC2 section and we will create a new instance using our newly created AMI. I will name the EC2 as web server 2, and AMI, I will select the AMI which we just created. I will just grab the AMI ID and I will just click browse more AMIs. Here I will just click on search. If you see in my AMI, I can see the AMI which we just created. I will just select it. So once the AMI has been selected, the architecture, the boot mode, everything has been copied from our AMI to this instance, and we have the option to change the instance type. I will go for t2.micro since it's a simple web page, and we have the option to change the key pair also. I will go with the same key pair, and network settings also we can change. We can launch this instance anywhere. We can also change the VPC and subnet everything, but I will just want to keep it as default. And existing security group I will select. I will use the security group which we have earlier used, which allows port 80 connection. And EBS I will just stick with 8 GB because our initial machine also had 8 GB, so I'll just stick with that and I will just click on launch instance. So we will wait until the instance has been created. Now the instance web server 2 has been created. I'll just try to grab the public IP and I will try to access it on the internet. Before that, I will close the previous web server which I have opened. I'll just close it and I'll just paste the new IP, of the web server 2. Now you see, we are able to access the content on the web server, which is identical to the content which is available on the web server 1. The point to be noted here is, here we just launched the instance with the AMI only. We not SSH into it, we not instant web server, and also we not changed any index.html. Everything has been copied from our old instance during the AMI backup process. So this is how powerful AMIs are. That's it for today's EC2 deep dive. I'd love to hear what you thought in the comment section. Don't forget to subscribe, and I will see you in the next session where we will explore something new and exciting. Until then, bye.